Okay, today we will work on some problems from chapter 2 review, exercise review. And I don't think I can finish all of them in one sitting. So I will call this chapter 2 review A. And I will not do all of them also at the same time. I will do the one that has the calculus one and try to avoid the technical part too much. Okay, so for example, if you see the chapter 2 review exercise number 1, I think the question is too vague or maybe something we already well covered in class. I don't think we need to go over that anymore. Then I will not do that. Okay, let's go with number 2. Number 2, the graph of function is shown. State with reason the numbers at which fx is not differentiable. We can see that it is not differentiable here. Okay, at what? -4. Fx is not differentiable at x equals to -4 because discontinuity. By the way, can you hear my son's TV sound?
No.
No? Okay, you're fine. Because otherwise then I will ask him to lower the volume. Okay, and then notice that we have corner here at x equals to -1, right? So it is continuous there, okay, but it is not differentiable because it's a corner. To be more precise, in that case, actually, we call that a cusp. Okay, it's like this. Something looks like this, or something look like this. It's something sharp. Okay, and then at 2, it is also discontinuous, right? To be more precise, at x equals to 2, it is not differentiable. It's because of asymptotes, vertical asymptote. Or I think we can also say because of the limit to infinity, infinite limit, infinite value. No, I don't like that term. Infinite limit is more appropriate. Okay, that's for number 2. Now, number 4, this is actually coming from section 2.2 or maybe 2.1. We basically step back and see, oh, you know what? What is the function? Find the fx and the number a such that the f prime a looks like this. Okay, now the way we see that is this. Notice that f prime a is equals to limit, if using the limit definition h approaching 0 of f a plus h minus f a over h, right? That's what it looks like. So we notice that the denominator already the same. Okay, somehow the top left here give us a feeling about what is the fa plus h look like, and later on we will confirm that with the fa. Now what I meant is the following. Notice that from there we see that fa plus h seems to be 2 plus h being to the 6, right? As if they are telling us that a equals to 2 and fx equals to what?
X to the power of 6.
That's correct. So fx is x to the 6. But we need to confirm with the fa. So if I see fa when x equals to 2, right? Fa equals to F2, that is 2 to the 6, right? What is that? I think that's 64, huh? That's 64, right? Now from there, then we realize, hey, you know what? So this is actually the first derivative. This is equals. What they ask us is only to identify what is the a and what is the function. So we are actually done. Okay, but since we know how to do the derivative already using the theory, right? So from there we can actually go further and answer this question. F prime x is 6x to the fifth, so f prime 2 equals to 6 times 2 to the fifth. That's 6 times 32. That's 192, huh? So this later on, not only we know what is the function and at what a, we can go even further saying that the value of this limit is actually 192. Does it make sense? So we actually go backward. Usually in the past, if we have the function and at what point to compute to evaluate the function, then we use the limit to compute, right? Now we go backward. Hey, we know the limit, and we can re-engineer to find what is the function, what is the a. Now then we use the formula, the derivative formula for exponents, and then plug the a in. Okay, so this question is actually not hard if you know the background, but it becomes very, very hard for those people trying to do it manually. In other words, if you try to do it from here, okay, then the only option is really to do the binomial expansion that you learn in pre-calculus. Okay, and the binomial expansion of 2 plus h to the 6, that's actually a long one. I mean, 7 terms, but in between, uh, the coefficient is kind of nasty, you know. Okay, so if you try to do it from there, neat binomial expansion, but since we are more advanced, then we can step back and do the derivative using the formula. Okay, now the next many questions is to find the y prime. And from the lesson we have in class, you see that we actually done up to here, okay, to find the derivative of a function. So let's do that. Number 14. Number 14, y equals to 1 over square root of x minus 1 over the fifth root of x cubed. Now, let me rewrite this in rational exponent. This is x to the negative 1/2 minus x to the negative 3/5. Okay, so the y prime will be negative 1/2 x to the negative 3/2 minus, it becomes plus, minus and another minus. Let me write it this way, minus negative 3/5 times x to the negative 8/5. Am I okay? Then this is negative 1 over 2 square root of x cubed plus 3 over 5 x to the, I'm sorry, the fifth root of x to the 8. But because the exponent inside the radical is greater than the index, we usually rewrite it this way, 2x square root of x. You see, x to the 3/2 is x to the 1 and 1/2, right? So that's x times x to the 1/2. That's x square root of x. Basically, when you divide 8 over 5, that's x to the 1 and 3/5, right? Now the 1, we write it as regular. The 3/5, we write it in radical, like that, okay? And with me, honestly, I'm okay if you stop here. If you stop here. But there's a chance our textbook wants us to rewrite this into common denominator. Okay, to rewrite that into common denominator. So let me mark it this way first. So if you write it in common, with me, I'm okay if you stop here now. But suppose we want to see how the textbook will rewrite it into common denominator. Notice that from here we see this is negative 1 over 2 x to the 3 half plus 3 over 5 x to the 8 fifth. Okay, now then we need to think about what is the LCD of you know what, not really LCD, something to do with yeah, common index, 3 half and 8 fifth. We have common 10, huh? We have common 10, so that will be what, 15 over 10 and 16 over 10. Is it right? Okay, so I'm actually never really do this, but let me try. Let me try. This is so 1 over 2 times x to the 15 over 10 plus 3 over 5 x to the 16 over 10. So the common denominator will be, if going further from here, I need to multiply this part here by another 1 over 10. So I multiply by x to the 1 over 10, x to the 1 over 10. Now then, for the coefficient of the denominator, I need 5 here, I need 2 here. So then I end up with negative 5 tenth root of x plus 6 over 10 x to the 16 over 10, which is x, the 10th root of x to the 6, which I can reduce to be x cubed over 5, x to the 3 fifth. So 6 minus 5 10th root of x. You know, if we do the LCD, which I don't think is common. I don't think it's common. That's why I do expect our textbook just let you stop here. Okay, but if the textbook go even further, it must have something to do with the simplification. Okay, yeah, let me just erase this here. Students who watch the videos will see what I talk about, but if those students don't watch the video, just see the PDF, then they don't see this further explanation. It's not important anyway. Yeah. Okay, that's number 14. I'm more into trying to save some space. Okay, number 16, let me do it here. Y equals to tangent x over 1 plus cosine x. It's a quotient. No way for me to simplify. So let me use quotient rule then. So y prime equals to, on the denominator, it will be 1 plus cosine x squared. On the numerator, let me rewrite that first. Tangent x prime times 1 plus cosine x minus tangent x times the derivative of 1 plus cosine x. Now, if you want to skip this step, go ahead. But in my opinion, rewriting it this way first enable us to, we don't need to worry about the structure, you know, u prime phi minus phi u phi prime over phi squared, those kind of formulas, because we don't need to compute and remember the structure at the same time. So what I did here, I just did the structure. Okay, and then from the next step, I do the computation, but I don't simplify yet. Okay, I just do computation. This is secant squared x times 1 plus cosine x minus tangent x times negative sine x. right? Now then, in the next step, I will simplify. So secant squared x times 1, that's secant squared x, plus secant squared x times cosine x is what? Now secant squared x is 1 over cosine squared, right? Multiplied by cosine x, that gives us 1 over cosine, which gives us just secant x. Okay, and then what is this here? This becomes plus tangent x sine x. On the denominator, we have 1 plus cosine x being squared. Now, I'm not aware if we can simplify this any way further. We do have extra secant here, though. We have extra secant here because we can rewrite this as, this is actually sine x over cosine x times sine x, right? Okay, so we can rewrite this as sine squared x times 1 over cosine x, which is secant x, if you want to go that far. So this may be, let me say that I don't mind you guys to stop here, but you may want to explore if this is possibly factorized, simplified further. At least we can see that we have common factor secant x. Over 1 plus cosine x being squared. Okay, now imagine if I factor the secant x on the top and then rewrite that as 1 over cosine x. So one of the secant x is taken away from the top and then rewrite as cosine on the denominator. Now the thing is, in physics especially, and therefore sometimes in math, you need to simplify a bit further, just in case something cancels further. Okay, just in case something cancels further. Now, so Thomas, during the test, how do I know that I can stop here or not? During the test, you can ask me, Thomas, okay, should I stop? Can I stop here or I need to go on? Okay? Yeah, I'm during the test. Your teacher is with you anyway, right? Yeah, I will be with you anyway in class. Number 18. Y equals to x plus 1 over x squared to the power of square root of 7. Now this is chain rule, u to the square root of 7. So y prime will be square root of 7 x plus 1 over x squared to the square root of 7 minus 1. Okay, be very careful with that radical. The roof of this radical should not extend too much. Okay, it's radical 7 as a number subtracted by 1. Not 7 subtracted by 1 and then you do the square root. No, 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 no. Okay, multiplied by the derivative of x plus 1 over x squared. Okay, now, but I will do that in the next line. Times 1, this is x to the negative 2, so negative 2x to the negative 3. So this is square root of 7 x plus 1 over x squared to the square root of 7 minus 1 times 1 minus 2 over x cubed. Okay, that's for number 18. Am I okay? Okay,
Yeah.
let me go. Yeah. Number 20. I think this is actually on the easy side. Y equals to sine of cosine x. So what is y prime? Y prime is, we see this as sine u, right? The derivative of sine u is cosine u times the derivative of u, in this case the derivative cosine, which is negative sine. It's simple enough that I do it all in one step, but of course, if you feel it's too complicated, like this one here is too complicated to do it in one shot, then I save it for the next step. I just rewrite it first. Okay, negative sine x times cosine of cosine x. That's for number 20. Let's go on number 22. Ooh, that looks kind of ugly, huh? Number 22, y equals to 1 over sine x, sine of, not sine x, sine of x minus sine x. I don't think I want to do quotient rule, especially because 1 over sine is cosecant. This is cosecant. Maybe I write it below that. Yeah, this is cosecant. Cosecant of x minus sine x. Now, the derivative of cosecant is negative cosecant blah cotangent of the same blah, right? Times the derivative of x minus sine x, the blah. So this will be negative 1 minus cosine x. I write the derivative first at the front, multiply by cosecant x minus sine x cotangent x minus sine x. Okay. Our textbook may, because of the negative and the subtraction, so we may reverse the order subtraction to get rid of the negative. Okay, so this cosine x minus 1 times cosecant of x minus sine x cotangent x minus sine x. Okay, but I'm okay with either one of what we have here. That's for number 22. Let me go on with number 24. This is the trigonometric derivative, huh? So number 24, y equals to secant of 1 plus x squared. The derivative of secant is secant tangent times the derivative of 1 plus x squared, right? So let me write that first because that happens to be a nice number. That's a 2x only, right? Derivative of 1 is 0, right? So 2x secant 1 plus x squared times tangent 1 plus x squared. Oh, not too long. Actually, this question is simpler than number 22. Oh, number 26. Implicit differentiation, huh? Because they get mixed up. So number 26, y plus x cosine y equals to x squared y. We do implicit differentiation with respect to x. So this will be y prime plus cosine y plus x times negative sine y times y prime equals to, let me slow down. This cosine y, x cosine y, we do product rule, right? So there will be derivative of x times cosine y plus x times the derivative of cosine y. Okay, now the derivative of cosine y, however, is negative sine y times the derivative of y. Okay, of course, on paper you have to copy everything. Don't do partial thing. Avoid doing things partially. And I do penalize points for doing things partially, you know. Okay. What usually happen is like you focus too much on the partial part and then you forget to put it back. And even if you put it back, you miss something. It happens way too often that no, avoid doing that. And then the one on the right hand side of equal sign, you know what? Let me just move it to the left so that the equal sign lined up. And then we do product rule again here. That's 2xy plus x squared y prime. Now, collect the terms with y prime on one side. Equals to 2xy minus cosine y. So this is y prime here. Now I factor the y prime out. You can write the y prime at the front, you can write the y prime at the back, up to you. I have a tendency to write y prime at the back. The reason is then I can see the y prime better. Usually if you write y prime and then after something, there's a chance that you miss that little prime notation. But this is very personal, very personal. Different people may see it differently. So the y prime will be 2xy minus cosine y over 1 minus x sine y minus x squared. Okay, I think that's the simplest we can get. You know what? I want to say something. If you have a fraction, a rational expression with subtraction on the top and subtraction at the bottom, there's a chance they actually write it in different order to make it look nicer with plus sign. What I meant is this. On the top, we may, let me write it using red color. They may reverse the order subtraction to get a negative. And at the bottom, they do the same thing. And notice that the subtraction disappear. I mean, the negative on the top and the bottom then cancel out. You see, they cancel out. So we may then just rewrite this as y prime equals to, on the top, we have cosine y minus 2xy. And then at the bottom, we have x squared minus x sine y minus 1. Okay? May go either one, either way. Number 28. Y equals to 1 over cube root of x plus square root of x. Ooh, this is kind of ugly, huh? This is x plus square root of x to the power of negative 1/3, right? If I rewrite that using negative exponent, I think it's easier to deal from this point of view. Okay, so y prime will be negative 1/3 times x plus square root of x to the power of negative 1/3 minus 1 is negative 4/3 times the derivative of the blah. Now then from there I get negative 1/3 x plus square root of x to the power of negative 4/3 times 1 plus 1/2 x to the negative 1/2. I don't know how ugly this will be, but let's try. This is negative fraction 1 here, and at the bottom we have do I want to rewrite that into cube root? Oh, let me write it this way first. X plus cube root square root of x to the power of 4/3, right? Times 1 plus 1 over 2 radical 2. 2 radical x, I'm sorry, not radical 2. Now then, On the first factor, I will break that to power of 4/3 becomes x plus square root of x to the power of 1. And the other 1/3, I rewrite that into radical. Okay? Now, on the other hand, this guy here, let me try to do the LCD so that I can multiply them later on. Okay, so this is 2 square root of x plus 1 over 2 square root of x. Okay, which then gives me negative of 2 square root of x plus 1 over, can you imagine what will this be if you multiply this? Actually, we have another extra. Let's see. I do it aside. Okay, I do it aside. So imagine square root of x times x plus square root of x. The first term is x square root of x. The second term is x. So notice that I can factor the x out, right? You see what I mean? Okay. Because that's the type of pattern we get, you know. So I will write this as x square root of x plus 1 square root of cube root of x plus square root of x. Okay. Yeah. Uh, of course, you may ask this question, Thomas. How do I know during the test that I need to go that far? Ask me. Okay. I have to be honest that if you can go as far as here, I'm happy enough. But I will definitely tell you to simplify further. Simply because. Which one do I? Oh, yeah. Simply because this is actually something we can simplify. Okay. That's something we can simplify. Now that's for number 28. Let me go on further. Number 30. Y equals to square root of sine of square root of x. Let me rewrite this as sine to the power of 1/2 of square root of x. Yeah, that way I worry about that square, the outer square root first, the one in the outside. So y prime equals to 1/2 sine square root of x to the power of negative 1/2 times the derivative of sine square root of x. Okay, that's 1 over 2 square root of sine square root of x times the derivative of sine blah is cosine blah times the derivative of blah. Okay, which will be that will be 1/2 x to the power of negative 1/2, so square root of x like this. Okay, let me simplify that right away. So that will be on the numerator we have cosine square root of x. On the denominator we have 4 square root of x square root of sine square root of x, which I think we can reasonably put. Either you put the radical x inside the square root of sine x, which I don't think that's what we would like to do. But we rationalize the square root of x. So square root of x cosine square root of x. I multiply the top and the bottom by square root of x. That's what I did. That way, at least I don't have square root of x at the bottom. 4x square root of sine square root of x. Yeah. Okay. I think that's the simplest we can get and reasonable to our way of usually write final answer in Calc 1. That's for number 30. Let's go on to the next one, number 32. Number 32. Now we have two variables here, though, x and lambda, but let's assume that the variable that we are dealing with is x and lambda is just a parameter or just a constant. So y equals to x plus lambda to the fourth over x to the fourth plus lambda to the fourth. I think I will do quotient rule, x to the fourth plus lambda to the fourth squared, while at the top that will be the derivative of x plus lambda to the fourth times the denominator minus the numerator times the derivative of x to the fourth lambda to the fourth. So you see I rewrite them first so that I see the structure. And then the next thing is I do the computation for the derivative. Okay, so anything else that I know for sure will be there, I copy that down. The derivative of this guy is 4x plus lambda cube times the derivative of x plus lambda is just x, right? Times x to the 4 plus lambda to the 4th minus this is x plus lambda to the 4th times 4x cubed. Is there anything I can cancel? I don't think so, huh? Oh, I have common factor on the top. Let's do that first. So on the top, at the bottom, I copy paste. On the top, I have 4x plus lambda cube is the common factor, right? I factored it out. So I have x to the 4th plus lambda to the 4th minus, I pull x plus lambda cube out. So I still have 4x plus lambda, one of them. I pull the 4 out and then I have x cubed, like that. Oh, something cancel later on. So I have x to the 4th plus lambda to the 4th minus x to the 4th minus lambda x cubed over x to the 4th plus lambda to the 4th squared. Okay, x to the 4th cancel. And on the in this group here, the lambda is still a common factor, huh? So 4 lambda x plus lambda cube. If I pull one of the lambda out, I have lambda cube minus x cube left inside over x to the 4th plus lambda to the 4th squared. I think this is the simplest I can go. Yeah. Unfortunately, we cannot avoid algebra. We cannot avoid pre-calculus in which you need to know how to simplify. Okay. So please focus on that skill also. Okay. Not just like idea. Oh, you know what? I know how to do the power rule, the derivative of a polynomial, derivative of sine, cosine, tangent, secant. Those are the things that we learn in this course, but simplifying process from pre-calculus is still something we need to maintain. Okay, and honestly, based on what I saw so far, that's the one lacking from a lot of students in Calc 1. Okay, in calculus in general, sine mx over x, the derivative will be, I think I would just do quotient rule. Okay, x squared on the denominator. On the numerator, the derivative of sine mx times x minus sine mx times x prime, which is just 1. The derivative of sine mx is cosine mx times the derivative of mx. I write it down, the derivative of mx times and then times x minus sine mx times 1. Okay, so this will be m cosine mx, actually times x, let me put that x here, minus sine mx over x squared. Oh, this question is a lot easier. That's number 34. Number 36. Let me do it here, since I have space, a little space. X tangent y equals to y minus 1. Find the y prime. So we do implicit differentiation with respect to x. On the left hand side, we have product rule, right? 1 times tangent y plus x times the derivative of tangent y is secant squared y times y prime equals to y prime minus 0. Oh, I think this one is not that bad, huh? Okay, so I think I will leave the tangent y on the left hand side and just move the x secant squared y times y prime to the right hand side. I will factor the y prime as usual. So y prime is equal to tangent y over 1 minus x secant squared y. Okay, now that's for number 40. I'm sorry, number 36. Let's go on. Now you will see the focus of your test 2 later on. At least the heavy part is the limit. Now, I'm sorry, the derivative. Now, after this section is applications, which implies that you still need to know how to do the derivative. Now, the nice thing about application is usually the function given to us, and at least that's the one I plan, is on the easier type of function that easy to do the derivative, because we want to focus on how to use that derivative. Okay, so in some sense, your teacher, me in this case, will try to make sure that the function is easy enough to do the derivative, so that when it comes to the follow-up question, you are using a correct, you tend to use correct derivative. Okay, now, but Thomas, what happened if I do the derivative incorrectly? Then something must be really bad, because your teacher must have used a simple function to do the derivative on. Okay, so later on in the application, what I'm trying to say, when it comes to the application, we tend to deal with easier function to do the derivative on. Okay, so that we can focus on the application, what the derivative means, what is the second derivative, and so on and so forth. Okay, now the one we are dealing with right now is we focus to make sure that we know how to do the derivative even for more difficult type of functions. Okay, yeah, so I'm not saying that later on we don't deal with the derivative anymore. We still deal with the derivative, but more into application. Okay, number 38. It's supposed to be an encouraging news though. So it's like, oh, Thomas, my derivative is very weak. You still need to study that. That's part of calculus, right? But it's not lingering with us for way too long. Okay. Number 38. Number 38 seems to be simple, but using that may not be that easy. So y equals to x minus 1, x minus 4 over x minus 2, x minus 3. Now, of course, you can FOIL this, the top and the bottom, and use quotient rule. Uh, what I think I will do is I use quotient rule without foiling it. Okay, why? Because the nice thing about x minus constant, when you do the derivative, that's equals to 1. Foiling it will mess it up, will mess up the structure. Okay, I will use that big property. Okay, first thing, when I write the derivative, I will rewrite them first. Okay, so the top one will be x minus 1, x minus 4 derivative times the denominator minus x minus 1, x minus 4 times the derivative of the denominator. I may need to do the foiling later on though, but let's save it for later. And then x minus 2, x minus 3 being squared on the denominator. Okay, now then the derivative here, the derivative of this guy here will be a product rule, right? It will be 1 times x minus 4 plus x minus 1 times 1. Okay, times x minus 2, x minus 3 minus x minus 1, x minus 4 times the derivative of this guy will be, I do product rule, 1 times x minus 3 plus x minus 2 times 1 over the denominator x minus 2 squared, x minus 3 squared. Okay, so from here, the red part here is 2x minus 5 times this thing here. You know what? Let me just FOIL that now. 2x squared minus 5x plus 6 minus x squared minus 5x plus 4 times 2x minus 5. Oh, the same thing. Surprise! Oh, okay. Now I have more faith. Because then we have common factor on the numerator, right? We have common factor. Let me give myself some space. Okay, so on the numerator, I have common factor 2x minus 5, such that I have x squared minus 5x plus 6 minus x squared minus 5x plus 4 over x minus 2 squared, x minus 3 squared. But on this part here, it's just they cancel, right? We have only 2 left. 6 minus 4. Ah, really nice. So this is 2 times 2x minus 5 over x minus 2 squared, x minus 3 squared. Oh, I didn't expect that to be that nice though. Really, I didn't expect that to be that nice. Interesting. Unless I make any algebraic mistake, but I think I'm careful enough not to make that kind of mistake. Yeah, yeah, I think I'm careful enough not to make that mistake. Hmm. You may want to try, you know what, let's try. Number 38, I redo it, but this time I FOIL that first. So y equals to x minus 1, x minus 4 over x minus 2, x minus 3. Suppose I FOIL that first. X squared minus 5x plus 4 and x squared minus 5x plus 6. So the derivative will be, or maybe in this case it's easier, I don't know. Honestly, I don't know earlier. I just expect that. The reason they purposely write it without foiling it Maybe because we should not FOIL that first. Okay, but who knows, right? So this is x squared minus 5x plus 4 prime times x squared minus 5x plus 6 minus x squared minus 5x plus 4 times derivative of x squared minus 5x plus 6. Now then, the denominator already as is. Notice that if I factor the denominator, I get the denominator of our previous answer, right? Okay, but on the numerator here, we get 2x minus 5 times x squared minus 5x plus 6 minus x squared minus 5x plus 4 times 2x minus 5. Notice that we actually have the same thing. Now we have this common factor, right? Oh, exactly the same basically right now. Okay. So I think I was thinking too much. Maybe foiling that first is better. Again, we never know. We never know. Okay, we never know. This going further. Let me just say dot dot dot. Then you will get the same thing. That's for number 38. Number 40. I need to write that. Let me make it. So y equals to number 40. Y equals to sine squared of cosine square root of sine pi x. Okay, so I copy the question right. More space, please. So what is the derivative? So this is sine squared, right? So the derivative of sine squared is 2 sine cosine of blah, right? Times the derivative of the blah. Oh, these factors here is just double angle, huh? This is just double angle. This is just double angle. Let me just do it. So that is 2 sine of 2 cosine square root of sine pi x. Now then I worry about the derivative of cosine, which is negative sine of blah times derivative of that blah. Okay, so this is equals to negative 2 sine of 2 cosine square root of sine pi x times sine square root of sine pi x times derivative of square root is 1/2 blah to the power of negative 1/2 times derivative of blah. So a lot of chain here, huh? A lot of chain rule. So the 1/2 here will cancel with the 2 here. So I have negative, just negative sine 2 cosine square root of sine pi x times sine square root of sine pi x. Oh, yeah, I want to say that I cancel this guy here. This guy cancel with this. Okay, and then this is square root of sine. pi x on the denominator. Let me put it this way. Square root of sine pi x on the denominator, okay, times derivative of sine pi x, that's cosine pi x, times the derivative of pi x, which is pi. Okay, this is the I don't want to copy everything again for this little thing here, so I just skip that little step. Okay, now then finally I put things together. Oh, dang, this is not fun at all. Too many chain rule. Yeah, too many chain rule put together. So this is pi cosine pi x sine of 2 cosine square root of sine pi x times sine square root of sine pi x over square root of sine pi x. Phew. So you notice, of course, if we step back, you may have this question, Thomas, will you really ask this question number 40 in the test? I don't have that interest, but it is a fair game. Okay, because this question is not really about do you know how to do the derivative of sine squared, do you know how to do the chain rule, do you know how to do the derivative of square root? No, it's not about those individually, but it's about those when they put them together. Okay, so we may be able to fight, like if from taekwondo point of view, you may be able to fight one person at once, you know, but can you imagine if you would need to fight them all at once? Okay, you know, now of course, even though you fight them all at once, one of the strategy is like how to separate them first, right, and then organize the work. So it's about all of them together, okay, and rewrite them properly. So it has to do with a lot to do with your skill in writing your work in organized way. Okay, remember in class, I emphasized that a lot. Okay, organize your work, organize your work. Because if you don't organize your work, you can only go this far, not far enough. Okay, let's go on further. Number 41 and 42, it's the second derivative question. I think that's similar. So I would just do number 42. So g theta equals to theta sine theta. The question is find g double prime pi over 6. So g prime theta equals to product rule, right? Theta prime sine theta plus theta times sine theta prime. Okay, the derivative of theta is 1 respect to theta. So 1 times sine theta. You don't need to write that one if you don't want to. In fact, you can just skip the step. So this is theta cosine theta. Okay, so we're done with the first derivative. The second derivative, we go on from there. So derivative of sine is cosine plus the derivative of theta cosine theta, product rule again. This is cosine theta plus theta times negative sine theta. So this is 2 cosine theta minus theta sine theta. Not too hard, right? But organize your work though. Sometimes if you don't organize it, especially the one of the bad habit, if you do things, you detach that. Okay, like this part you put it somewhere else, this part you put somewhere else. Okay, you tend not to see them as a big picture anymore. Okay, my suggestion is if that's what you want to do, do it on your scratch paper. Okay, but then on your test paper or your quiz paper, your homework paper, keep that organized. Now my teacher, This is actually from my middle school teacher. She actually says this. Usually, our notes in math, our math notes, we can always write it in 2 columns of the regular paper, right? But she said this. You can take away approximately 1/4 or 1/3 of the most right-hand part and make it your scratch paper, you know. And this is your main work. This is your scratch part. If you don't have scratch paper, okay? If you don't have scratch paper, when she gave us quizzes, she doesn't give us scratch paper. She say just choose the side of the paper I give you, you know. So but she, even from middle school, my middle school math teacher already emphasized that to me. Okay, so why do I say it about my middle school teacher? I'm just trying to say that the idea of organizing your work is not something coming from Thomas. In fact, it's already done by those mathematicians from many decades. Okay, it's not because, oh, Thomas, you just being picky. No, I'm not. No, no, I'm not. Okay. Number 44. Find the nth derivative. Oh, it seems like the general formula, huh? Find the nth derivative. So number 44, we need to find pattern then. Fx equals to 1 over 2 minus x. Let me rewrite that instead of using doing quotient rule. Let me just rewrite that as negative exponent. So f prime x equals to negative 2 minus x to the power of negative 2 times the derivative of 2 minus x, which is another negative 1, huh? So this is negative 2 minus x to the negative 2 times negative 1, which is just 2 minus x to the negative 2. Is right? Which is 1 over 2 minus x squared. Now, if I do another derivative, I do it from here. That's negative 2 minus x to the power of negative 3 times the derivative of 2 minus x. That's another negative 1. If I simplify, this is 2 minus x to the power of negative 3 of 2 over 2 minus x cubed. Let's do one more time. Let's do one more time. I hope we can see some pattern. The third derivative will be 2 times negative 3 times 2 minus x to the power of negative 4 times the derivative of 2 minus x, which is negative 1. So this will be, now I start seeing something else. I originally thought that the nth derivative of x will be n over 2 minus x to the power of n minus 1 and n plus 1. That's what I thought. But apparently we have 6 now, which is coming from 3 times 2. So this is 3 times 2 over 2 minus x to the power of 4. Huh. You know what? Let me do one more time. So the fourth derivative of x will be to the power of negative 4, huh? So that will be negative 4 times 3 times 2 of 2 minus x to the power of negative 5 times another negative 1. So that's 4 times 3 times 2 over 2 minus x to the 5th. It seems like we need to use factorial, huh? This is 4 factorial over 2 minus x to the 5th. And then later on we do the derivative of the to the power of negative 5. I have 5 factorial. Oh, then I think the general formula for this is n factorial over 2 minus x to the power of n plus 1. I think that's the pattern. Okay, that's for number 44. Number 45 and 46, find the limit. I think we will use the two special limits we learned in, I think, is it 2.4? Maybe 2.4 or 2.5, I don't remember. The two special limits, just to remind ourselves, limit that theta goes to 0 of sine theta over theta equals to 1. Another one that we will use is limit theta goes to 0 of cosine theta minus 1 over theta equals to 0. Is it right? Is it the one? Yeah, I think that one. Yeah, I think it's this one. These two. Okay, so those are the things we will use. So number 45, I have secant, I have sine. Confusing. Let me rewrite. This is 1 over cosine. Hey, but hold on. This will go to 1, right? If I just plug that in. Is 0 in the domain? I think so, huh? Hold on. So it's not as hard as what I thought. Secant 0 equals to 1. Okay, sine 0 is 0, right? So it's in the domain though. So the limit of that is secant 0 over 1 minus sine 0. Secant 0 is 1 over 1 minus 0. That's just 1. Oh, okay. That's simple. Huh. I thought it's harder. It's hard. No. That yeah, 0 happens to be in the domain of this function. So we can just plug that in. Now, but for number 46, that's not the case though. You will get 0 on the top and tangent 0 is 0. Okay, so I need to rewrite this. This is limit t approaching 0 of t cubed. Okay, remember I also have one that our textbook didn't mention, and I think they have a reason of that. Limit x approaching 0 of tangent theta over theta also equals to 1. Okay, so let me use that here. Okay, let me use that here. So at the bottom we have tangent 2t being cubed. Okay, I can my purpose is this. I will need to have 2t cubed on the top over tangent 2t being cubed at the bottom. Under condition of limit 2t goes to 0, this will be 1 cube, which is 1. Okay, that's what I'm gonna do. That's where I'm going. For that reason, then it seems like I need to multiply by 2 cube on the top and 2 cube at the bottom. So this becomes limit t goes to 0 of 2t cubed over tangent 2t being cubed. I don't need to rewrite it that way, this way actually. Times 8, 2 cube at the bottom here. Now then, this is 1 over 8 limit t goes to 0 of 2t cubed over tangent the cube 2t, just to emphasize that the argument is 2t there. Okay, and therefore, since if t goes to 0, then consequently 2t also goes to 0. Let's call this u. So this is 1/8 limit u goes to 0 of u cubed over tangent cube u, which is 1/8 times 1 cube, which is 1/8. Okay, now notice what I did here. I use my formula that our textbook didn't didn't provide. So can we do it textbook way, Thomas? Let's try. Let's try. First, what I will do is I will rewrite tangent cube as sine over cosine cube. Okay, so this is sine cube of 2t over cosine cube of 2t, which is equals to multiply the top and the bottom by the LCD cosine cube. I get t cube cosine cube 2t over sine cube 2t. Now then from here I multiply by 2 cube on the top and 2 cube at the bottom. Okay. Then I have limit t goes to 0 of 2t cube cosine cube 2t over sine cube 2t. Oh, I missed the 2 cube, the eighth on the denominator. So actually what I have here is very similar to what I have here already. Very similar. But Thomas, what about cosine cube? Imagine if you replace the t by 0, you will get cosine cube 0, which is 1. Okay, which is 1. In other words, I can now write it this way. This is 1/8 limit t goes to 0 of 2t cube over sine cube 2t times cosine cube 2t. Okay, and because the limit exists, let me just skip one step. So I can multiply it by the limit of product equals to product of limit. Okay, so this becomes 1/8. This becomes 1 cube. Okay, and this becomes limit u goes to 0 of u cube over sine cube u. Okay, which basically goes back to this, right? Okay, you can use the first method I gave you earlier, of course, by knowing limit x going to 0 of tangent x over x is equals to 1. Or you can also use number 46, but you need to show how you change the t cube becomes 2t being cubed such that it match with the argument of tangent, the argument of sine. When we say argument, is this one, the angle. Okay, this we call that the argument. Okay, that's the argument of the function, the input of the function. That's for number 46. Okay, let's go on. Number 48, find the 47 and 48 are basically the same question, right? Find the tangent line. Okay, and trust me, you will have this type of question in your test for sure. Standard question. This is standard question. Should not be a surprise. But at the same time, I need to find the tangent line, so the function is supposed to be something I can easily do the derivative on, at least not a difficult one. Okay, so y equals to x squared minus 1 over x squared plus 1, such that the derivative is, if you don't practice, of course, everything is hard, right? Because everything you do during the test will be the first time you do it. But if you practice at home, at least you already have some experience on doing that problem. Even if all the experience you have is making mistakes, at least you know what kind of mistakes you get used to do. If you don't do and if you don't practice at all, no, that will be the first time and you have no experience even in making mistakes. Thomas, everything sounds really easy for you. No, it's not hard. It's not easy for me. You don't know how hard I studied before. Okay. And you don't know that the reason I asked you to study because that's the path I went through. Okay. So no. I'm not saying that it's easy. I'm saying that if you practice, things becomes easier. That's what I say. Okay. Yeah. But not practicing, basically you kick the can down the road and then everything becomes so hard toward the end. And then you say, "Oh, Thomas, I don't have time to study." No, you have time to study. You didn't study. You don't manage your time. Please do. Okay, please do. I can tell you when are things, when is things is too much. Okay, but for example, taking calculus one class during winter, that's a lot. Okay, but not studying during this winter just make it worse. Okay, this is 2x cubed plus 2x minus 2x cubed plus 2x over x squared plus 1 squared. So 2x cubed cancel, we have 4x over x squared plus 1 squared. So that's the first derivative, right? Now then the first derivative at 0, comma 1 or at 0 only as the x is 0, that's 4 times, Am I doing it right? 4 times 0 over 0 squared plus 1 squared. So the slope is 0? That's way too nice. If the slope is 0, then the equation must be y equals to just a constant of x then. I mean, constant of from the y. I mean, it's y equals to 0x plus b, right? And then when you plug in numbers, when you plug in x equals to 0, and the y is -1. So we know the b is -1, right? So the tangent line is this equation of tangent line is y equals to -1. That's way too easy though. I didn't expect that. Let me check, just in case I make a mistake. I don't think so, but yeah, I think I'm okay. Yeah, the fact that the slope is 0 is just like, wow, too nice. That's for number 48. Number 50. Find the equation of the tangent line and normal line to the curve at the given point. Oh, number 50. We need to do implicit differentiation, huh? So x squared plus 4xy plus y squared equals to 13. This is a tilted ellipse. I know, no, I expect this to be an ellipse, but apparently because the coefficients are the same, this is just a circle then. Huh. But maybe not. Maybe not. I don't know. I don't know. Should I try to graph it? Let me try to graph it. I would like to know that too. Okay, so x squared plus 4xy plus y squared equals to 13. Oh, it's not. I thought it is. I really thought it is. I thought it's a circle. It's hyperbola? Huh. You can see my screen, right? Yeah, you can see my screen. Oh, wow. Okay. I expect that to be a circle because I see x squared plus y squared. Anyway, coming back here. Uh, so by implicit differentiation with respect to x, this will be 2x plus 4y plus 4xy prime plus 2y prime equals 0. Now I plug in. You can solve for y prime first, but I think I would just plug in numbers first and then solve for y prime. Okay, at 2, comma 1, we have 2 times 2 plus 4 times 1 plus 4 times 2y prime plus 2 times 1y prime equals 0. That's 8 plus 8y prime plus 2y prime equals 0. So y prime equals to negative 8 over 10, which is negative 4/5. Okay, so the equation of the tangent line. The equation of the tangent line will be y minus 1 equals to negative 4/5 times x minus 2 plus 8/5 plus 1. So negative 4 over 5x 13 plus 13 over 5. Okay, now the slope of the normal will be negative reciprocal, so that's 5 over 4. So the equation of the normal line at that point will be y minus 1 equals to 5 over 4 x minus 2. I think that one is simple, right? 5 over 4x plus, no, minus 5 over 2. I cancel with the denominator, plus 1. So y equals to 5 over 4x minus 3/2. Okay, that's for number 50. Let's see more. Number 54. Find points on this ellipse where the tangent line has slope 1. So we have, let's say we have an ellipse. I think this ellipse is supposed to look like, let's say it looks like this. I have this, so let me use this. Let's say this is the slope, the ellipse, the one that have slope 1. If like that, then it must be this. And to be honest with you, I expect that because this ellipse actually centered at 0, right? At origin, because this ellipse happens to center at the origin. So I expect the points where it has the same slope must be on opposite side. Must be on opposite side. Okay. At least visually, that's what we see, right? Okay. But let's try it. Let's try it. X squared plus 2y squared equals to 1. We do implicit differentiation with respect to x. I get 2x plus 4y prime equals to 0. Oh, now I see why. Okay, so this is 4y prime equals to negative 2x, y prime equals to negative x over 2y. Okay, okay. We need to set this equals to 1, which implies negative x equals to 2y, right? Yeah, so for the slope to be equal to 1, it must be on this line beside it is on the ellipse. It has to be also on this line, which if we think about that, that's actually slope negative 1/2. Okay, that's what I expect though. So think of this is y equals to negative 1/2 x, right? It's visually, geometrically, has to be on this line. You see? Then it shows that it is the opposite side of the origin, right? Okay. But I need to find the points though. How to do that? Substitute the x in there. Make it nicer, Thomas. Okay. So this is negative 2y. I substitute the x. negative 2y squared plus 2y being negative 2y being squared plus 2y squared equals to 1. So I have 4y squared plus 2y squared equals to 1. So y squared equals to 1 6. Y equals to plus minus 1 over square root of 6. So we have two different y's that corresponds to two different x. So let me continue here. When y equals to 1 over square root of 6, the x will be what? I will use this one here. This is y equals to negative x over 2, right? I'm sorry, x equals to negative 2y. So multiply by negative 2. So this is negative 2 over square root of 6. Let me rationalize this. So multiply by negative 2, that will be negative square root of 6 over 3. So this is one of the coordinate, negative square root of 6 over 3, square root of 6 over 6. Now, while for y2, when we have negative 1 over square root of 6, that's negative square root of 6 over 6. Then the x2 will be negative 2 over square root of 6, which is, no, plus. This is now becomes plus, which is square root of 6 over 3. They are the opposites. Both of them. Those are the points that has the tangent line equals to 1. Number 56, how many more? A lot more. Okay, but I think I can finish this in at most half an hour. Okay, let's go on further. How many tangent lines to this curve pass through the point? X over y equals to x over x plus 1. It would be nice if you can figure it out, but if not, that's okay. So this is the vertical asymptote is at x equals to negative 1. The curve look like, I think the curve should look like what? Horizontal asymptote is 1. So the curve should look like this. We don't need to know what the curve look like. No, we don't need to. But the question is, how many of the line pass through the point 1, 2? 1, 2 is here. Okay, so I expect to have one line cutting this way and another one line like this. Okay, I expect two, maybe more, but visually we have two. Okay, visually we have two. Yeah, visually I have two. So let me use this color then. So this is one of them. This is another one. But whatever I feel, I need to prove that. Okay, I need to prove that. Now, I did this similar question in class. The plan is this: I will do the derivative first, okay, and use this derivative later on as the slope of a line. Derivative of x times x plus 1 minus x times derivative of x plus 1. So that would be x plus 1 minus x over x plus 1 squared. So that's 1 over x plus 1 squared. Now, you may think, oh, you know what? Can I just plug this in, Thomas? No, 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 no. No, you cannot plug this in because this point 1, 2 is not on the curve. It's not on the curve. Our tangent line will pass through that point 1 comma 2, but this 1 point 1 comma 2 itself is not on the curve. Okay, what we can do is we use that, okay, the line passes 1 comma 2 with slope 1 over x plus 1 squared, where the x here is on the curve for x, y on the curve. Okay, because we know it must pass this coordinate, then we must have y minus 2 equals to the slope times x minus 1. Okay, it must be like that. On the other hand, the xy here is on the curve, so y is a function of x. This is x over x plus 1 minus 2 equals to this. Okay, that's the equation we need to solve. Okay, let's multiply the left hand side and right hand side, because that's a rational equation, right? So I will multiply by the LCD x plus 1 squared. That will give me x times x plus 1 minus 2 times x plus 1 squared equals to x minus 1. So this is x squared plus x minus 2 times x squared plus 2x plus 1. Notice that we have quadratic equation. That will give us two solutions. Minus 3x, minus 4x. I make the other side become 0 right away. And minus 1 equals to 0. Oh, okay. So x squared plus 4x plus 1 equals to 0, huh? Am I missing anything? I think I'm okay. Yeah. Now, you can use quadratic formula, but I think I will use completing the square here. Well, because the x squared has coefficient 1 and the coefficient of x is even, it's easier to do completing the square if it is not factorable. I will add both sides by 4. At this point, I hope you already know why I add 4 to complete the square. So x plus 2 squared equals to 3. So x equals to negative 2 plus minus square root of 3. That's the x. So from here, we can answer the first question. There are 2 points. How many tangent? 2 tangent lines, as we expect. At which points do this tangent line touch the curves? We already have the axis. We need to find the y, right? Okay, let me give myself more space. For x equals to negative 2 plus radical 3, I know that's so ugly, huh? The y will be, the y is x over x plus 1, right? X over x plus 1. So this is negative 2 plus radical 3 over negative 1 plus radical 3. Rationalize the denominator, multiply by the conjugate. Negative 1 minus radical 3, negative 1 minus radical 3. The denominator, negative 1 squared minus radical 3 squared. While on the top, when I FOIL, I get 2 plus 3 radical 3. No. Positive 2 minus 1 plus radical 3 only. Minus 3. So that is -1 plus radical 3 over -2. Let me move this to the bottom. Which is 1 minus radical 3 over 2. I cancel the negative for each terms. That then means the coordinate is -2 plus radical 3, comma 1 minus radical 3 over 2. Honestly, the answer is so ugly that I start questioning if I did everything correct. My bad, my bad. Let me check. The derivative, I think, is okay. Multiply by x plus 1 squared. I'm checking my work just in case I make any algebraic mistake. So far I'm good. The second one is if I have the conjugate, so x minus equals to -2 minus radical 3. So the y will be -2 minus radical 3 over -2 minus radical 3 plus 1. So this is -3 minus radical 3. Huh. No, that's -1 minus radical 3. What am I doing? So multiply by the conjugate 1 minus radical 3. 1 minus radical 3. That will give me so -2. 2 minus 1, so that's plus radical 3 plus 3 over, I factor the negative, so that will be 1 minus 3. So that's positive 2 at the bottom, and the top I get 1 plus radical 3. So that corresponds to -2 minus radical 3 and 1 plus radical 3 over 2. Those are the two coordinates on the curve at which the tangent line will pass 1, 2.
Professor, I have to
Yes.
go now.
Oh, that's okay. Don't worry. Yeah. Thank you, though.
Thank you.
Yeah. I will continue just a bit more.
Yeah.
Mm. Number 69 and number 70. Find hx in terms of g prime, in terms of f prime and g prime. Let me try number 70. So h prime x equals to f prime of g sine 4x times the derivative of g prime of sine 4x times the derivative of sine 4x is cosine 4x times 4. Okay, so h prime x will be 4 cosine 4x times f prime of g of sine 4x times g prime of sine 4x. Okay, let's try number 69. I tried to skip that, but I think that give us, doing this problem may give us some maturity. Okay, I will do quotient rule here. The quotient rule have the denominator f plus g squared, right? On the top, I will have fg being prime times the denominator minus fg times the derivative of the denominator. Okay. However, on the top left, the first factor, I need to do product rule. F prime g plus fg prime times f plus g minus fg times the derivative of sum is sum of derivative. Let me do to the right. I will distribute next. So this will be f prime g. I do FOIL, huh? Plus f prime g squared plus f squared g prime plus fg g prime. That's on the FOIL of the first term on the left, on the top left. The top right will be f prime g minus f g prime over f plus g squared. Now I think I can do canceling. This guy cancel with this guy cancel with this. So we get f prime g squared plus f squared g prime over f plus g being squared. Okay, let's go on. Number 86 and 88. We did this problem similar to this problem earlier, number 6 as I remember, right? Okay, so they give us the limit and we reinterpret that as the derivative of a function at certain point. Okay, so number 86, for example, you see limit x approaching 1 of x to the 17 minus 1 of x minus 1. Now think of this as limit x approaching a of fx minus fa over x minus 1 as the derivative of the function at a. Okay, you can visually do the matching that you see that a equals to 1 and the fx equals to x to the 17, right? And in fact, we confirm that f1, which is the fa, equals to 1 to the 17, which is 1. This way, we can do the matching that this guy is this guy is this. Okay, such that the yellow one with the green one put together give us fa. Okay, so we come back. This is this expression here is equal to the derivative at 1 for fx equals to x to the 17. Now the derivative is 17x to the 16. So f prime 1 equals to just 17. We reverse engineer that, right? Okay. For number 88, similarly, notice that the a equals to pi over 3. The function is cosine theta. And to confirm, f pi over 3 is cosine pi over 3 cosine 60 degree, which is 1/2. Okay, so this is equal to f prime pi over 3 for f theta equals to cosine theta. Okay, so f prime theta equals to negative sine theta, and f prime pi over 3 is negative sine pi over 3, which is negative radical 3 over 2, which I do expect you to memorize. Okay. Yeah, I think that's it. This is for just the first part of, which is majority already, I think, for chapter 2 review. Okay, I think in a couple days I will do chapter 2 review where I do more application problems. Okay, application to science, natural science, as I remember, social science, and also the application into graphing maybe. Okay, and the limit to infinity stuff. I need to see further. Okay, but as I remember from what I saw earlier with the chapter 2 review, a lot of them is just application. So the assumption after this is you already know your derivative. Okay, that's for today.